I want to recall the antiderivative. Remember that y is equal to the integral of f of x dx, which we write with this funny symbol here. We say that y is the antiderivative of f of x. That is, y is the function whose derivative dy dx is the function f of x. I want to focus in on this equation here. Dy dx is equal to f of x. This equation is a special kind of equation known as a differential equation. We call it a differential equation because it involves the derivative, dy dx. In this section, we're going to be focused on differential equations and their solutions. You may be asking yourself at this point, why would I be interested in solving differential equations? One way to answer this is to point out that Newton's law, F equals ma, can be thought of as the differential equation, F is equal to m dv dt, or F is equal to m d squared x dt squared. So when we're modeling a physical system, it's often natural to describe the system in terms of a differential equation, such as when using Newton's second law. We'll show an example that uses differential equations to model a problem involving a zip line after you've learned the basics in this section. I said we're interested in solving differential equations. So what does the solution of a differential equation look like? Well, here we know the solution because we defined the solution to be the antiderivative. Y is the indefinite integral of f of x dx. Note that this is a special kind of solution. You're used to solving equations like x squared minus 1 equals 0, whose solution, x equals 1 and x equals minus 1, is 2 points. When we solve a differential equation, the solution is the antiderivative, which is a function. But it's more than that. Remember, the antiderivative is not unique. There are many antiderivatives that differ by a constant. So the solution to this differential equation is not one function, but rather a family of functions. You'll see that this is true in general. The solution to a differential equation is a family of functions that is a collection of infinitely many functions. This means that there are infinitely many solutions to these differential equations, f is equal to m dv dt and f is equal to m d squared x dt squared as well. Later on, we'll see how we can pick one solution by using initial conditions. For now, you're going to do some problems thinking about the units of differential equations and their solutions.